Welcome to Solar Cycle 25 update for November of 2023. Let's take a quick summary of what went on in the last month. Sunspot numbers are still increasing towards solar maximum. For example, the smooth sunspot number is at 124, that's 7% above the peak of Solar Cycle 24. We had 194 C flares in November, that's up 1% from October. We have 17 M flares, that's up 143%. Unfortunately, we had no X flares, but there's been some time since we've had an X flare. Coronal mass ejections 185, that's up 18%. And we had 8 geomagnetic storms, that's double the number we had in the previous month, and some of the events were much stronger than in previous months. So let's take a look at sunspot numbers. This is the sunspot plot from the Solar Influences data center in Belgium. Yellow here is the daily averaged sunspot number. The blue is the monthly average sunspot number. And the red, the solid red, is the smooth sunspot number. And that's really the important one. There's a couple of models tacked onto the end there in dashed curves. We'll talk more about those later. However, you can see that the smooth sunspot number is already above that of Solar Cycle 24, shown on the left here. The monthly average sunspot number for November was 6% higher than that in October. I keep track of the areas of sunspots over time, and this is the plot so far. One of the things that's noticeable here is they seem to come in bursts. The overall trend is upwards, although the last couple of months has been pretty thin. However, if you look at the separation of these bursts, the typical period is something like 180 days. Now that's significant from the point of view that back in the days of solar maximum mission, and that's the early 80s, the gamma ray group there thought that the gamma rays emitted by the sun came in bursts of about 180 days. I'm wondering if there's something fundamental here. But if you're given the 180 days, they would say our next burst should be sometime in January or February. Let's take a look at the progression of Solar Cycle 25 with respect to the various models that were forecast. The top model here is the sunspot number as determined by the NOAA-NASA panel, the red line that is. The grey area is the uncertainty on that. You can see that the sunspots have been well above that for most of the cycle so far. They're perhaps edging down towards it now, but we'll see how that goes over the coming months. The F10.7 centimeter radial flux is rather similar, but it's been well above the model and is continuing to be so. It's not even within the grey uncertainty area. So both of these say that we're going to have a fairly active cycle. Now let's take a look at the standard predictions. First model on the left here is what's called the standard curves method. That follows the curve of a typical solar cycle. And you can see that it's predicting that we're going to have a maximum of about 160 with a peak in June of 2024. The second one is what's called the combined method. It uses several different methods of predicting the solar cycle. That is less aggressive, and it's a peak of about 135, but it's still going up at the peak of 135 in the December of 2024. This goes 1 year ahead of where we currently are, I should say. The last one on the right is the McNish-Lincoln method, which again is fairly modest. It has a peak of 135 and generally peaks towards the end of 2024. So we'll see how these are right. However, one of the things to notice here, the shaded areas are the uncertainties in those models, and they are quite large. Let's take a look at the growth of sunspots. We can do that by plotting the number of sunspots for the month of November. That's in red here with a black outline. And I've overplotted the same number for one rotation prior to this. So if you see blue above the red, then there was decay in the current rotation. If the red is above the blue, then there's growth. And you can see on the left, we had a minimal amount of decay in those initial longitudes. But for the last couple of weeks of the month, we've had significant growth in sunspot number. I keep track of the latitude of sunspots as the cycle goes along. And this is a plot of the average latitude for each month of the sunspots that appeared during that month. In orange at the top we have the northern hemisphere, in blue at the bottom we have the southern hemisphere. And as you can see, they are doing as expected. They're migrating slowly towards the equator. Now I fitted a straight line fit to this, and the equations for those straight lines are noted on the plot. Well, what does this mean? Well, if you solve this equation, the sunspots will reach the equator, and that comes out as 116 months. You do the same for the southern hemisphere, and that comes out to a remarkably similar number, 114 months. If you average those, it would say that most solar minimum would start, i.e. that's when the sunspots reach the equator and disappear, in about August of 2029. So we're going to have a relatively short cycle of about 10 years, or just under. And then we'll be in solar minimum conditions for 6-12 months, and then the new cycle will start. I also track the number of major sunspot regions. These are regions that are large enough and long-lasting enough that NOAA actually ends up numbering them. And you can compare solar cycle 24 with solar cycle 25 after a certain equivalent time. So I'm measuring this from the solar minimum date of each cycle and then going on to see what the current rates are. And you can see that solar cycle 25 has been steadily outpacing solar cycle 24 for basically the last 3 years. And solar cycle 25 is now about 22% above in terms of number of numbered regions than solar cycle 24 at the same stage. So that also points to a somewhat more active cycle than solar cycle 24. As I said previously, the smooth sunspot number is the most important factor here, and that's because that's how you measure when solar maximum was and when solar minimum was. And this compares the smooth sunspot number for solar cycle 25 so far with the solar cycle 24 smooth sunspot number, both measured their respective solar minimums. And you can see that solar cycle 25 is not only outpacing solar cycle 24 considerably, but it's also already past the peak of solar cycle 24. At the moment, it's running about 35% above solar cycle 24. Now let's take a look at a sunspot video. This is from the Solar Dynamics Observatory HMI instrument in its optical channel. It's a 28-day movie, which is approximately one rotation, from the 2nd to the 29th of November. It's running at 15 frames per second. Note the growth in the number of sunspots in the last half of the movie. I keep a count of the number of flares, and I break them into the 3 categories: C flares, M flares, and X flares. You can see the C flares were running about 90% ahead of solar cycle 24 at the same stage. So that indicates it might be a very active solar cycle. If you do the same thing for M flares, there's an even larger gap. It's now running 139% above solar cycle 24. So again, it would indicate a very active cycle. Unfortunately, we're not having very many X flares. While solar cycle 25 is ahead of solar cycle 24, it's only just, and the statistics of the numbers are too small to be useful. We can also look at coronal mass ejections. Here, the number of coronal mass ejections as numbered by the LASCO coronagraph on SOHO is running about 30% ahead of solar cycle 24 at the same stage. So it would indicate a larger cycle, but not necessarily a spectacularly so one. So let's take a look at the videos of the coronal mass ejections. This again is from the Soho-Lascaux C2 coronagraph. It's a 28-day video at 15 frames per second. So how much does this space weather affect what's going on at Earth? We've had lots of events, and you'd expect a larger number of magnetospheric events such as geomagnetic storms. And that has in fact been the case. We have 7 geomagnetic storms. That is anything at or above the level of 5 on the KP index. So what conclusions can we draw from all of this? The growth of solar cycle 25 may have slowed a little, but it's still on its way to a new solar maximum. It's not there yet. The maximum of solar cycle 25 will be larger than solar cycle 24, probably in the area of 160 to 200, and will probably occur sometime in 2024 or 2025. We're getting many small flares, but not a lot of large M or X flares. That's somewhat surprising, but there is a rule of thumb that we get most of those during the decay phase of the cycle, not during the rise phase. Geomagnetic activity seems to be on the rise, but it's not reached a level that would concern our technology at the moment. It is safe to conclude there will be no grand solar minimum this time around. That's it for today, folks. Thank you for watching. Until next time, stay safe and goodbye.